This is an overview of our toolbox for corporate finance. And in particular, what we're focusing on right now is capital budgeting. And to remind you, capital budgeting is about determining whether a project is worth pursuing. And at its core, it's a cost-benefit analysis where we weigh the cost to the benefit of the incoming cash flows and to decide whether it's worth it. So for all of the examples that we look at, we're starting at the basic level. So we're going to only look at projects with a conventional setup that includes a cash outflow at time 0 and cash inflows beginning at time 1. So if I were to draw a timeline of the typical project that we look at, it's going to be negative at time 0 and positive throughout the rest of the timeline. So we're paying today to get invested in a project to receive cash inflows in the near future. So each of the methods that we talk about provides a slightly different perspective on this cost-benefit analysis. And in practice, managers use multiple methods. And so it's important to understand the pros and cons of each method and to understand the perspective that you're getting from any particular method. Now, the ones that we're going to be looking at are the payback period, the discounted payback period, the net present value, internal rate of return, and profitability index. Now, the most important method here is going to be the net present value. And it's the one that gives us the best idea of how much value is created for the firm from any given project. All right. Now, for these problems, we're going to be using the cash flow mode in the calculator. And, just so you know, every financial calculator kind of does it in a similar way, but each has its unique aspects to it. So what I recommend is, for whatever calculator you're using, stick to that one and get good at it. So then, you feel comfortable and you don't get confused on the exam. What I'll be using is the BA2 Plus. So it's the app on the iPad, but it's the same one that is on the calculator, on the physical calculator. All right. So the first problem is calculating the payback period. Now the idea is simple, right? So we have a cost of the project that we have to incur today, and we're essentially asking ourselves, how long is it going to take to get fully repaid? And so you can see for this project, the cost is $18,000, and that's what we'd have to pay today to get started. And you can see in year 1, we generate $4,500. Year 2, we generate $7,500. And year 3, we generate $10,000. Year 4, it's $8,500. So the question is, how long does it take to get paid back? So all we have to do, we can write out $18,000. Now we have to go year by year until we fully collect the $18,000. So year 1 is going to be $4,500. So we collect $4,500. And that brings us to $13,500. Year 2, we collect $7,500. So we continue to subtract $7,500 and we get $6,000. We continue in year 3, we collect $10,000. Now notice that $10,000 is greater than $6,000. So we get fully repaid in year 3. But in order to count this, what we can do is divide how much we have left, $6,000, by what we generate in year 3, which is $10,000, and that gives us 0.6. So the answer here is going to be fully year 1 and fully year 2 and partially year 3, 0.6. So it's going to be 2.6. So what's our payback period for this project? 2.6 years. Now, how does a manager use this? Well, you can see this provides some practical perspective on, whether, we get repaid in a timely manner. So what you might find is that some projects generate a really high internal rate of return or really high net present value, but the payback period is just too long, right? It takes too long. It's not really a practical thing. So what we like about the payback period is that it provides some practical perspective. Notice that what we're doing here is not, discounting or anything like that. So we don't involve the time value of money. And so therefore that's the greatest weakness of the payback period. But it does provide some good perspective on practicality. All right. So now we can calculate the discounted payback period using a discount rate of 15%. And this is done basically the way that you would expect. We take each of these future cash flows and discount them to present value. And then using their present value, we calculate the payback period in the way that we just did. So $4,500 will be discounted at a rate of 15% over 1 year. That gives us $39.13. Year 2, $7,500 will be discounted over 2 years at a rate of 15%. And that gives us $56.71. And then we have $10,000 discounted over 3 years at a rate of 15%. And that gives us $65.75. And then we have $8,500 discounted over 4 years at a rate of 15%, and that gives us $48.59 or $48.60. Okay, so now these are the numbers we're going to use to calculate the payback period like we just did a minute ago. So we take the full 18,000 and we go year by year and subtract out the amount that we bring in each year. But in this case, we're using the present value of the future cash flows. So the first is $39.13. So we do 18,000 minus 39.13, and that gives us 14.87, still unaccounted for. So we take that and we go to the next year and subtract out 56.71, and that gives us 84.16. Okay, so we still have 8,416 unaccounted for, so we go to the next year and subtract out 65.75. That gives us 18.41. So we still have 18.41 unaccounted for, but you can see in year 4, we collect more than what is unaccounted for, and so therefore we can divide 18.41 by 48.60, and that gives us 0.38 basically. All right, so now let's recap what we just did. So we used all of year 1, okay? We used all of year 2, and we used all of year 3, but we only used part of year 4. So the answer is going to be 3, let's see, I'll write it, 3 point, what we used in year 4, 38. So what is the discounted payback period for this problem? It's going to be 3.38. 3.38 years. All right, now we can calculate the net present value. All right, so what do we do? So to understand this project, you can see what's happening is that we're incurring a cost of $18,000 upfront at time 0. And in return, we're collecting these cash flows in years 1 through 4. Now, what we'd like to do is compare the cost of $18,000 relative to the benefit of these future cash flows. But to really compare apples to apples, these future cash flows have to be in present value terms. And so therefore, essentially what we're doing in calculating the net present value is calculating the present value of all the future cash flows, which are cash inflows, and we're subtracting out the cost of $18,000 up front. Right? So that's essentially the idea of the net present value. It's a cost-benefit analysis that gives us a result in dollar terms of how much the benefit is worth relative to the cost. Now, we like a project if the net present value is positive, because if it's positive, then what it says is that the benefits outweigh the costs. All right, so let me show you how to do the calculation in the calculator. Now we're going to be using what's called cash flow mode. So you can see up by the second button, there's a CF, which stands for cash flow. So I press cash flow and it brings me into cash flow mode. And before I get started, I want to make sure that I clear out anything that was left over, because I don't want anything that I've done in a previous problem to carry over into the current problem and mess up my work. All right, so what happens at time 0? We incur a cost of $18,000. So for the cash flow 0, I'm going to put in negative $18,000. I'll press enter. So now what I've done is I've set cash flow 0 to negative $18,000, saying up front I'm going to pay $18,000. So then I press the down button and it brings me to cash flow 1. So for cash flow 1, you can see that I have a cash inflow of $4,500. So I'll press $4,500, enter, and that sets the first cash flow to $4,500. And I go down and you can see it gives me F01, which stands for the frequency of this first cash flow. Well, you can see I only incur the $4,500 once. So I'm going to leave it at 1. But if I were to have incurred it at, for several different times, then I could put in how many years it repeats. All right, so I continue going down and you see it gives me cash flow 2. So I put in $7,500. Enter. Frequency 1. Cash flow 3 is $10,000. Enter. Frequency also 1. And then lastly, year 4 is $8,500. Enter. Frequency 1. Okay. So now what I've done is I've entered all of the entire timeline into the calculator. So now it understands the timeline. Now I have to tell it to perform the analysis. So I press NPV and it says, what is the discount rate? Because you need a discount rate to calculate the NPV. Otherwise, you can't discount the future cash flows. So the discount rate in this case is 15%. So I press 15, enter, and I go down and it says the NPV, you need to compute it. So I press compute, 3,019.19. Okay, so the answer here is that the net present value of this project is 3,019. So what does that mean? Well, it means that if we pursue this project, if we pay $18,000 today, and in return, we receive these future cash flows over these 4 years, then we're increasing the value of the firm by $3,019. Okay. All right, so next we calculate the internal rate of return. So the internal rate of return is conceptually slightly different because what we're doing is we're not using a discount rate, and instead we're saying, okay, given this set of cash flows, if I were to invest $18,000 and receive these cash flows over the next 4 years, what would be my rate of return on that $18,000? Okay, so it's conceptually a little bit different from the NPV. Rather than trying to compute an actual dollar amount of value created, which is the NPV, instead now we're trying to figure out what is my overall rate of return given these cash flows. Okay, all right, since everything is already inputted into the cash flows into the calculator, what I'm going to do is go ahead and calculate IRR. Now, I press IRR and it says 0. That means I have to compute it. So I press compute and it says 22.19. So what does that mean? That means if I were to invest 18,000 and if I were to receive these cash flows in return, my overall rate of return over these 4 years would be 22.19% per year. That's what the IRR represents. Now, when do I accept a project based on the IRR? Well, I need something to compare it to, right? 22.19 may sound good, but I don't know what I have it to compare to. So I need a discount rate. And so using the discount rate from before, if the discount rate is 15% and this project's IRR is 22.19%, do I like it? Yes, I do. Because 15%, you can think of 15% as being like my minimum threshold. I'm not going to accept anything that is less than 15%. And since this project generates 22.19%, it's greater than 15%, I like it. Okay. But I need something to compare it to. And as a side note, we're going to get into a little bit later on what determines these discount rates. But one way to think of it now is being kind of like a reflection of the riskiness of the project. Or it could be related to alternative options, right? Maybe you're looking at a variety of projects and, they all generate more than 15%, so you don't want to invest in something that generates less than that. Or you might think of it as being a particularly risky project, and because it's risky, you want your return to be high, and so you've decided your minimum allowed threshold is 15%. Whatever the case, we'll get into that later, but the important thing for the IRR in terms of the decision of whether to accept or reject a project is whether the internal rate of return is greater than the discount rate, the benchmark. Okay. Now, lastly, we can compute the profitability index. Now, the profitability index is very similar to the NPV in the sense that the NPV looked at the present value of the benefits minus the cost. But the NPV is in dollar terms, and the profitability index is a ratio. So the NPV was the present value of benefits minus the cost, whereas the profitability index is the present value of benefits divided by the cost. So in a way, with the ratio, with the division there, essentially what you're doing is scaling by the project size, or at least by the initial cost. So that scaling kind of adjusts for the size of the project, and therefore you may get different conclusions, especially comparing project to project, different conclusions when using the NPV versus the profitability index. Okay. Now, with the NPV, we found that the value created was $3,019. Now, remember the NPV represents the present value of the benefits minus the cost. So knowing that the cost is $18,000, we can infer that the present value of the benefits is $18,000 plus $3,019, or $21,019. Do you see that? right? Because the NPV equals the present value of benefits minus the cost. So if you add cost back to NPV, then you get the present value of the benefits, which is 21,019. So we're going to use that number to calculate the profitability index. So 21,019, which is the present value of benefits, divided by the cost of 18,000 gives us $1.17, basically. Okay, what does this mean? Well, it means if the profitability index is greater than 1, then it means that the benefits outweigh the costs. So essentially, the decision rule with respect to the profitability index is whether the index value, the ratio, is greater than 1. Because again, if it's greater than 1, then the benefits outweigh the costs. Now, what makes this different from the NPV? Again, like I just discussed, the NPV gives you the dollar value amount created, whereas the profitability index is a ratio where you divide by cost rather than subtract the cost from the present value of benefits. And because it's a ratio, it scales by size. So when you're comparing multiple projects and they're different sizes, then you may get different results when looking at NPV versus the profitability index. Okay, so let's kind of compare and discuss. So what is the primary purpose of the payback period method? Well, the payback period tells you how long it takes to get paid back. And that can be important. It's not exactly reflected in the NPV, right? Or the IRR, or the profitability index. And so therefore, the payback period, which doesn't necessarily take into account the full timeline of cash flows, because all we care about is how long it takes to get paid back. So while there are some weaknesses to the payback period, and we definitely don't want to use it by itself, it is good to use in conjunction with, or in addition to, the NPV, because it adds some practicality. So the purpose is to figure out how long it takes to get paid back, but why we use it is because it adds some dimension of practicality that is valuable. So which one of these ratios gives the greatest indicator of how much value will be created for the firm? The most direct result is going to be the NPV. And so therefore, out of all these methods that we've discussed here, the NPV is going to be the most theoretically sound or the most useful. Why? Because it tells you how much dollar value amount is created for a given project. Not just the return. The return is a good measure, a good aspect to it, but it doesn't exactly tell us how much value is created. And so the NPV is the most powerful method in terms of that. What is the term for the specific discount rate that makes NPV equal to 0? Okay, so this is moving on beyond just knowing how to calculate each one of these. It's important to understand the relationship. Now, we've already sort of discussed the relationship between NPV and the profitability index. But the relationship between NPV and IRR is extremely important. So when I ask for what is the term for the specific discount rate that makes NPV equal to 0, the answer is the internal rate of return. So if I were to calculate the NPV, so if I go back a few slides, I found the IRR was 22.19%. If I were to calculate the NPV using a discount rate of 22.19%, then I would find that the present value of benefits is exactly equal to the cost, making the net present value equal to 0. So that's probably the most important aspect to understand about the relationship between the NPV and the IRR is that the IRR is the rate of return that makes the NPV equal to 0. It's the point at which the benefits equal the cost. Now, if I go above and beyond the IRR, so if I go up to 25% and I were to use a discount rate of 25% for this problem, then I would find that the present value of benefits would be less than the cost. Because I'm using a discount rate less than 22.19%, I'm finding the present value of benefits is greater than the cost. And then again, if I were to use exactly 22.19%, the present value of benefits would be exactly equal to the cost. So that is the relationship between the NPV and IRR. So if you see on the exam, I say, choose the term that represents the discount rate that makes NPV equal to 0. In your head, you should immediately think, oh, that is the internal rate of return, the IRR. Okay, and then lastly, does an increase in the discount rate have a positive or negative effect on the NPV? So I sort of just touched on that, but if I go back to this NPV problem and I were to use a discount rate greater than 15%, if I upped it to 25%, then what does that do? Well, remember, I'm using the discount rate to calculate the present value of all these future cash flows. And if I increase the discount rate, then there's more discounting that is occurring. And so the present value of these future cash flows is going to go down. And so how does that impact my NPV? Well, the present value of future cash inflows would go down, and therefore it would push down the net present value. Okay, so does an increase in the discount rate have a positive or negative effect on the NPV? And the answer is negative. All right, and one last thing to talk about. Conflicting rankings between each of these measures. Now, it goes back to what you really need to understand. It goes back to what is produced by each of these measures. And for NPV, what is produced is the dollar value amount created. Okay, so it's in dollars. Whereas the profitability index is a ratio and the IRR is a percentage. Okay, so you can think of it as them being related but just different and providing different perspective. And therefore, it is possible to have some conflict with respect to the rankings of projects. But for all of these, the accept-reject decision is not going to change. They all should be consistent with one another. For example, if I go back and look at this IRR, the accept-reject decision is based on whether the IRR that I computed is greater than the benchmark discount rate, 15%. And what's going to happen is that the NPV will always be greater than 0 when the IRR is greater than 15%. So therefore, the accept-reject decision of these are all the same. But when I have multiple projects that look good and I would accept them, but I can only choose one, then I may have conflicting rankings. And one important aspect of this is project size. Because the profitability index represents a ratio and the internal rate of return is a percentage, they effectively control for size, whereas the NPV does not. Right? So you may have a small project with a very high internal rate of return or profitability index, but it's just small. So it doesn't create, as much value in terms of just overall dollars as another project that may be large but have a slightly lower internal rate of return. So you can imagine if I have a team of people and I'm trying to decide which project to let the team pursue. And I'm looking at, two projects. One is small, but with high IRR, and the other is large, but with lower IRR. I'm still going to choose the one with the higher net present value, because what I care about is just overall dollar value amount created. Okay, I hope that makes sense. So project size matters a lot. And then one last thing, and this is getting on the verge of things that you don't really have to know yet that you may study in future finance classes, especially, just to really solidify your understanding of what NPV and IRR actually are. The NPV assumes a reinvestment rate of at the discount rate, whereas the IRR assumes reinvestment at the IRR. Reinvestment is where you have cash flows that occur in the middle of the timeline that are then reinvested and earn some rate of return. So, and that's pretty much it. If you guys have any questions, just send me an email. I'm happy to